afternoon, students. So today we are going to see an important concept called feature engineering. Okay, part of this you have already studied and you have already discussed as part of NLP. In the unit 1, we talked about vectorization. You remember? Yes? We convert some of the strings and characters to numbers. We studied about monarch encoding, we studied about label encoding, we studied about count vectorizer, TF idea, word to vector. All of them are all basically help you to create the numerical representation of the data. Right? So, one thing very important in machine learning, AI, ML, deep learning, all these topics, of course NLP of our subject, AI, ML, deep learning, NLP, or any machine learning work, we need to ensure that we do a proper feature engineering and proper data pre-processing. We studied about text pre-processing, correct? Yeah. We studied about text pre-processing, data pre-processing, and data cleansing correctly. Why we have to do this? Garbage in, garbage out. Yes or no? So rather, instead of giving the entire garbage, I do some data wrangling, I do some data scrubbing, I do some data massaging, I do data cleansing, data pre-processing, I do feature engineering, so that I am not passing the garbage to the processing, right? So what basically the feature engineering is a process or a technique, set of techniques. Engineering means what? Putting things into a structure, correct? Why you are studying computer science engineering? You are studying the right method, right methodology. Engineering is a structured method following some discipline. Science gives you the rules, formulas, etc. The basics. The basics are converted, put it into a structure. They are making a product. And engineering design will design this tube that become a product. Electrical engineering product from electrical engineering is this tube light. The product from electronics and communication engineering is a sensor. A product from computer science and engineering is hardware or a software. We do a structured methodology and disciplined approach to build something. So, feature engineering is a systematic methodology to look at the data, given data, and whatever feature, whatever attributes, whatever data point which will be helpful for my machine learning model, for my decision making. So, the feature engineering sits between data set and machine learning model. This machine learning model can be classification model, clustering model, NLP model, any machine learning algorithm, decision tree, random forest, right, isolation forest, support vector machine, Bayesian classifier, K nearest neighbor, K means clustering, right? Any neural network based algorithm. We studied about transformer, right? CNN, RNN, and LSTM, logistic regression, linear regression. There are many ML models are there, right? So, if I do a proper feature engineering, then these machine learning models perform better. The performance of the ML model will be better and model will be simple because I am not giving the garbage. I have done my feature engineering. For example, simple example, there are 30 records, not 30 records, there are 13,000 records are there, and I have 15 columns in each record. Right? Dhanush, some boy, some girl name, 30,000 students, records are there, 15 columns are there, 15 attributes. For example, student ID, name, date of birth, age, mobile number, address, father's name, so on and so forth. Then we also have mark 1, we have mark 2, mark 3, and then maybe 3 marks. For example, these mark 1, suppose one company is coming, the company is interested to hire you, provided you got super marking M1, M2, M3. I want top 10 students. Classify the students. Please understand my words. The problem is what? Classify the students based on high M1 mark, high M2 mark, high M3 mark. There are 3 domains. Somebody may be NLP, text and speech analytics. யாரெல்லாம் நிறைய மார்க் வாங்கியிருக்கா, யாரெல்லாம் டீப் லேர்னிங்ல நிறைய மார்க் வாங்கியிருக்கா, யாரெல்லாம் மொபைல் அப்ளிகேஷன்ல நிறைய மார்க் வாங்கியிருக்கா. புரியுதா? ஏன்னா மொபைல் அப்ளிகேஷன் டீமுக்கு ஒரு M1 எடுத்துப்போம், M1 ஹை மார்க். இப்போ இதுதான் என்னுடைய டார்கெட். I know how to build classification. உங்களுக்கு என்ன டிசிஷன் ட்ரீ தெரியுமா தெரியாதா? டிசிஷன் ட்ரீ கிளாசிஃபையர் தெரியுமா தெரியாதா? Yes or no? Support vector machine தெரியுமா தெரியாதா? Some machine learning model தெரியுமா தெரியாதா? You know how to classify this data. Now data கொடுத்தா based on the mark வச்சு ஹையா லோவா கிளாசிஃபை பண்ண முடியுமா முடியாதா? Yes or no? இப்போ அப்படி பண்றதுக்கு முன்னாடி நம்ம என்ன பண்றோம்னா we are doing the teacher engineering. And do you need age? Do you need date of birth? Do you need male or female? Who cares? I want topper. Topper in M1. Topper in M2 among 30,000. So, in the 15 columns, 15 attributes of the data, I have done my teacher engineering and only taking the student ID maybe. I may need an ID, some name I need. Either I take a ID or name, any one. I don't want you to do. Just take name. Name. I need mark 1. I need mark 2. I need mark 3. Then I am going to create some new feature. It's called derived feature or custom attribute that is not available there. So I am going to create top underscore M1, top underscore M2. I'll give you what is that. Top underscore M3. Right? So right now this is not needed. Let's see how many columns we are looking for. Only 4 columns. Appa, do I need other 15 columns? Do I need other 11 columns? No. If I give you everything to a machine learning model, it is going to give. If there is no feature engineering, then data is very clumsy. We don't know what we have to do. Now I am very clear. What is the important feature? Mark 1 is an important feature. Car color is an important feature. Car kilometer is an important feature. Right? Not car manufacturing date. I wanted to buy a car which is less than 3,000 kilometers, second-hand car. So there, my feature is what? I am looking for 3,000 kilometers, less than 3,000 kilometers. I don't care about car color, model, how many seats and all. I don't care. Right? So whatever feature makes sense, whatever feature gives value to the business, to the ML model, only we retain that remaining we are going to chop it out. So we will have, if you do that, the classification algorithm is going to be simple and performance easy. We can do linear regression easily. We can do easy classification. Easy idea. You can convert into low. In the mark, which is the category 1, category category 2, category 3. இந்த ஒர்க்க பண்றது மெஷின் லேர்னிங் மாடல். இந்த மார்க்க வச்சு category 1 அது சொல்லும். Top, medium, above. For example, என் category என்னன்னா above 90 அப்படின்னா டாப் category. இந்த category 1ல டாப் இருக்கும். 70 to 89 அப்படின்னு இருந்தா செகண்ட் டாப்பர் இல்ல மீடியம் அப்படின்னு இருக்கும். 70 below. So 50 to 69 அப்படின்னு இருந்தா ஆவரேஜ். அவ்வளவுதான். அவனுக்கு யார் வேணும்? டாப்பர் வேணும், மீடியம் வேணும். அவ்வளவுதான். அது ஈஸியா கிளாசிஃபை பண்ணலாம் இல்லையா? You can write the program to classify. புரியுதா இல்லையா? For this one we can do, for this one we can do, for mark to complete. அது வந்து an algorithm can do. If I don't do this feature engineering, what would have happened? No feature engineering. அப்படியே ஏதாவது இருந்தா எல்லா ரெக்கார்டிங் பார்க்கணும், எல்லா காலமையும் பார்க்கணும், எல்லா டைரக்டரியும் பார்க்கணும், algorithm பண்ணி போயிடும். So algorithm become complex and performance also become slow. புரியுதா? Are you following me? So feature engineering is a process of enhancing the data, enhancing the given data so that machine learning model can can perform better and model can be simple. I don't want to give garbage to my machine learning model. Rather, I do some nice engineering activity. Okay, va? 4 activities we do in feature engineering. Note buddy, feature engineering task. First, understand the feature. Feature understanding. What feature we do? Feature engineering has 4 important tasks. Feature understanding. என்ன feature எதுக்குன்னு புரியும் இல்லையா? நான் புரிஞ்சதுனால தான் மார்க் 1, மார்க் 2, மார்க் 3 எடுத்துட்டேன். புரியுதா? ஓகே. So first என்ன? We need to understand the feature. முதல்ல புரிஞ்சிக்கணும். என்ன feature இருக்கு? கலர் தான் என்ன? எதுக்கு அந்த கலர்? என்ன டேட்டா டைப்? We should explore about all the characteristics of the feature. புரியுதா? ஒரு டேட்டா கலெக்ட் பண்ணா இல்லையா? சென்சார் கலெக்ட் பண்ணிருக்கு. அது எதுக்காக கலெக்ட் பண்ணு புரியாம நானும் மெஷின் லேர்னிங் ப்ரோக்ராம் வேண்டாம். I will do the clustering சொல்லி அப்ளை பண்ணா பேசிக் ப்ரோக்ராம் சொல்லலாம். புரியுதா? Agadish வந்து சார் I will do the program that give you the sensor எடுத்து உள்ள போட்டு கிளஸ்டர் பண்ணி 5 கிளஸ்டர் வந்துச்சு. ஒண்ணும் புரியாது யாருமே. Rather, he understood what is the sensor, what are the attributes which is given, which is an important feature. எதை வச்சு நம்ம வந்து heat check பண்ண போறோமா? What else you are going to check? Temperature or heat or air pollution, dust, what that you are going to collect. அந்த feature மட்டும் தான் நம்ம எடுத்துக்கணும், right? So first you need to understand the feature. Number 2, feature structuring. Feature structuring. சில feature வந்து ஒழுங்கா இருக்காது. So we are converting into some proper structure. Text எல்லாம் நம்பரா மாத்துறோம். இப்ப என் போட்டோ இருக்கு. என் போட்டோ machine learning model அண்டர்ஸ்டாண்ட் பண்ணிக்கணும்னு நினைக்கிறீங்களா? சத்தியமா இருக்காது. All my images are all transformed into numbers. Matrix ஆ மாறிடும். இப்ப என்ன போட்டோ எடுத்தா நம்ம எல்லாரையும் போட்டோ எடுக்கிறோம். இதுல யார் வெக்டர்ஸ் அது கண்டுபிடிக்கணும்னா every photo will be taken. We build a matrix. Vectorize பண்ணி ஒரு matrix create பண்ணிடுவோம். அந்த matrix-ஐ வச்சு கம்பேர் பண்ணி தான் you will identify these vectors. ஏற்கனவே பேஸ் அங்க இருக்கும். அந்த பேஸையும் என் பேஸோட மேட்ரிக்ஸ் வேல்யூ மேட்ச் பண்ணி எஸ் he is vector, he is Jagdish, he is Dhanush அப்படின்னு சொல்லி சொல்லுவோம். புரியுதா? ரைட்? ஸோ அதுதான் feature structuring. டேட்டாவை ஒரு ஃபார்மலைஸா ஸ்ட்ரக்சர் ஆகும். நம்பர் 3, feature optimization. We can improve the feature. இருக்கிற feature-ஐ அப்படியே வெச்சுக்காம I will tell you some example. Feature optimization or improvement. Feature optimization / improvement. The last one is feature evaluation. Feature evaluation. Both this one. one is feature understanding. என்ன feature, என்ன பண்ண போறோம்னு புரிஞ்சுக்கணும். ரெண்டாவது ஸ்ட்ரக்சரிங் பண்ணணும். மூணாவது ஃபர்தரா இம்ப்ரூவ் பண்றோம் அந்த ஃபீச்சர்ஸ் தேவையான மாதிரி. அப்புறமா அந்த ஃபீச்சர் கரெக்டா இருக்கா இல்ல ரிசல்ட் ஒழுங்கா வரல. அப்ப இந்த ML M23 மட்டும் பத்தாது. வேற ஏதாவது ஒரு ஃபீல்ட் வேணும்னு சொல்லி டிசைட் பண்ணிட்டு we are proceeding further. நம்ம அப்ரோச் கரெக்டா இல்ல. ML மாடல் வந்து நீ கிளாசிஃபிகேஷன் மாடல் பில்ட் பண்ணிட்ட. கன்ஃபியூஷன் மேட்ரிக்ஸ் வாங்கிட்ட. precision accuracy ஒரு 80 70 16 இருக்கு நிறைய எரர். அப்ப நம்ம செலக்ட் பண்ண ஃபீச்சர் சரியில்லை. So we need to evaluate and then again go back, understand the feature, do the structuring, do the optimization. புரியுதா? Is that clear? Yes or no? Okay, இன்னொரு எக்ஸாம்பிள் சொல்றேன். இப்ப என்கிட்ட ஒரு டேட்டா செட் இருக்கு. used car data set. hello, used car data set. ஒரு 10 வருஷத்தோட used car data set எங்க இருக்கு? அதுல வந்து மாருதி கார் இருக்கு, ஹோண்டா இருக்கு, Hyundai இருக்கு, Toyota இருக்கு, BMW இப்ப நிறைய கார் இருக்கு. இப்ப அந்த காரோட டேட்டால காரோட பேரு, எவ்வளவு கிலோமீட்டர்ஸ் ரன், நிறைய இருக்கு டீடைல்ஸ், என்ஜின் டைப், பெட்ரோலா, டீசலா, மேனுவலா, ஆட்டோமேட்டிக்கா, ஒரு 50 அட்ரிபியூட்ஸ் இருக்கு. இப்ப உங்க பேர் என்ன? சுதீர். Sudhir is right. Exactly. Stop. Hey, what is there? The joke here? Is there anything joke? Is there any joke there? Okay. Sudhir or some customers are interested in buying car which is less than 3 years old. Less than 3 years old. Some customers are interested having car which is color red. Red color car எனக்கு வேணும். அவ்வளவுதான். Some customers are having one requirement of less than 3 years. Some has red color. Okay. Fortunately, நம்ம டேட்டா செட்ல காரோட கலர் இருக்கு. ஆனா அந்த ஏஜ் இல்ல. நம்ம கொடுத்த டேட்டால ஏஜ் இல்ல. ஆனா என்ன இருக்குன்னா கார் பர்ச்சேஸ் டேட் இருக்கு. இல்ல கார் மேனுஃபேக்சரிங் டேட். இந்த கார் கண்டிப்பா ஒரு டேட் இருக்குல்ல. இன்னைக்கு மேனுஃபேக்சர் பண்ணிருக்கா, இன்னைக்கு ரெஜிஸ்ட்ரேஷன் பண்ணிருக்கா, நான் வாங்கின கார் 2018 or 11 or whatever time. So for example 1/1/2018 ல என் கார் வாங்கிருக்கேன். இப்ப I want to find out car age. How do I find it out? ஏன்னா சுதீருக்கு or somebody else they are looking for less than 3 years old. எப்படி நான் கண்டுபிடிக்கிறது? Try. IT la they got money from me by answering the question. How do you do it? Somebody say current year yaar pesra? நீதானே? who is speaking? யார் பேசுறாங்க? நீதானா? இப்போ இன்னைக்கு என்ன டேட் பைத்தான்ல போட்டா வருமா வராதா? இன்னைக்கு டேட் டைம் போட்டு இந்த இயர் பிரிண்ட் பண்ண முடியுமா முடியாதா? So I am writing one small function. அந்த டேட்டா ஃப்ரேம்ல இருக்கிற அந்த காலம் இருக்குல்லையா, நான் புதுசா ஒரு காலம் ஆட் பண்ண போறேன். I am adding a new column called car underscore age அப்படின்னு ஒரு புதுசா ஒரு காலம் ஆட் பண்ண போறேன். This is feature improvement. And அது எப்படி இருக்கும்னா இந்த வருஷம் now today dot year minus அந்த ஃப்ரேம்ல என்ன இருக்கும்? அந்த மேனுஃபேக்சரிங் டேட் இருக்குமா? டேட் ஆஃப் மேனுஃபேக்சர். அப்ப எனக்கு அந்த இயர் கிடைக்கும். இன்னைக்கு என்ன இயர்? 2024 minus 2018 எவ்வளவு? ஆறா 6 இயர்ஸ் தரலையா? அப்போ ஒன்றும் பண்ண மாட்டீங்க. So Sudhir is not interested in this car. He is not interested in my car. என்ன கார் முதல்ல இருக்குன்னு பார்த்துட்டு less than 3 years old car, 1 year 2 year around 3 years 2 year 9 months அந்த கார் மட்டும் தான் எனக்கு ஃபில்டர் பண்ணி வரும். சில பேருக்கு I want only red color car. இதுதான் feature engineering. I am going to give you one beautiful Python program wherein we are going to fully analyze all the feature, select a particular feature, extract particular feature. We are going to drill down the feature, converting the feature into categorical representation. Also, sir, why are you teaching this now? You might ask, because I didn't teach you AI before. I was directly getting into these units, right? So there are 4 types of data. Normal data, numbers, right? And also we have text. What we are studying, text and speech analytics, right? So we have text, and then we have audio, we have video, we have image. This is called TAVI. D TAVI வச்சுக்கோங்க. D னா என்னன்னா numerical data. உங்களுக்கு எல்லாருக்கும் டேட்டாவை டீல் பண்றதுக்கு தெரியும். ஒரு டேட்டால ஃபீச்சர் இருக்குமா? கஸ்டமர் டேட்டால some features will be there. டெக்ஸ்ட்ல ஒரு features இருக்கும். ஆடியோல features இருக்கும். வீடியோல features இருக்கும். ஐனா இமேஜ். இப்ப என்ன ஒரு போட்டோ எடுத்தா என்னோட ஃபேஸ்க்கு சில ஃபீச்சர் இருக்கும். hair color, wearing specs, yes or no. இதெல்லாம் ஃபீச்சர் இருக்கும். புரியுதா? அப்ப என்ன பண்ணனும்னா இந்த ஸ்ட்ரக்சரிங்ல I am also converting the images, audio, video into lot of numbers. இது எல்லாம் தான் வந்து speech. So நான் speech recognition எல்லாம் பண்ணவே முடியாது. If I don't do the proper feature, நீ சும்மா audio play பண்ணலாம், video play பண்ணலாம். But if you want to improve the voice, increase பண்ணலாம், change பண்ணலாம், reverse பேச வைக்கணும் அப்படினா I should know the right features. Okay, note down all these things. Okay, pause the recording. I'll give you the code and then I'll explain the code. Okay, she's giving you the definition. Speech engineering has multiple definition. First definition, how data science is called.
Features needed for supervised models.
Start from the beginning. Speech engineering. For some data scientists.
For some data scientists, feature engineering is how we narrow down the features needed for supervised models.
How we are going to drill down car age, car color, mark. What is the attribute which is interested? Narrowing down, drilling down. Number 2.
For others, it is the methodology. For others, it is the methodology used to extract numerical representations from unstructured data for an unsupervised model. Example, trying to extract
first one is drilling down, narrowing down. Second one is converting into numerical features.
Trying to extract structure from a previously unstructured data set.
So you can go down. Images. Any images are there. Images are converted into matrix. Text we convert into vectorization, right? We do the encoding. Stop it. Excuse me. Look at the diagram. I'm repeating. Giving the. Excuse me. Recap of what I just covered. So basically, you have potentially very complex problem, real-time problem, that may be customer segmentation, fraudulent data, or any data, any complex problem is given, right? So if the data is poorly extracted, poorly engineered, or not engineered, that leads into a complex model and very slow machine learning model. Even you are very intelligent, I mean, you have a very good program also, the program is going to go slow. But if data which has been properly feature engineered, nicely pre-processed, and we get a model will be, machine learning model will be simpler. At the same token, they also perform better, it gives a better metrics also. Right? So you have seen, there are 4 tasks in feature engineering. Generally, when I say feature engineering, I will understand the feature and I will structure the feature, I will optimize the feature, I will evaluate the feature. I am understanding first what is the feature, color, gauge or something. I structure it, convert it into some format, and then I improve the feature. Then finally I evaluate the feature. Age or feature choose பண்ணிட்டு அந்த age select பண்ணிட்டு understand பண்ணிட்டு select பண்ணிட்டு I am just optimizing it. I am evaluating the age correct இருக்குமா, date of birth correct இருக்குமா, age வேண்டாமா, வேற என்ன choose பண்ணலாம். You know, that is the feature engineering task. Feature engineering are 5 types. Some people in industry they just use feature engineering for improving the feature. You are going to the appointed day. What do you want? You are going to be appointed in industry tomorrow as an NLP expert. You will be only working on improving the feature. The feature of character of integer of where color, where dimension. Feature improvement, feature construction. You construct new feature, you reconstruct the feature. Some people only with the domain knowledge, they select the feature, then we extract particular feature, and then we learn from the feature. Okay. So now we take your domain. I have given you the program for a complete feature engineering program. So basically, the program is a complete feature engineering program. What we are doing is taking the car data set and we are adding the feature, dropping the feature, selecting the feature, improving the feature, extracting the feature. All those things we are going to do in that one program which I am going to demonstrate. Stop. Now, about the basic base, in continuation of some of the basic principles, we have discussed about coordination, right? So, we start from -1 to 1. Discuss that if any variables between input variable and output variable or variable 1 and variable 2, we find the association and we find the coordination. Based on that, we will decide the feature. So, feature engineering can also apply coordination technique, normalization technique, transformation techniques, right? And one other thing is, when I am selecting my features, I also need to identify anomalies. What is that? Anomalies or outliers. I don't want to take some features which are like so vague right hand side, so vague left hand side. We see that right in the normal distribution, right? Right? So anything is like this, beyond here, we don't do it, right? We don't take it. So anything between the mean, this is mean. This is what we are interested mostly, right? So in that context, it is one of the basic data science principle called 5-point summary. What is that? 5-point summary. Using this 5-point summary, we can represent any data to get the structure, to get an idea of any data. We can do 5-point summary. That can be drawn using a chart called box and whisker plot. Box and whisker plot. Again, okay. So, for example, I have some customer orders. Abhinaya, Sandhya, Tara, Tanya, Malvika, somebody went. They have purchased some change, some orders. Okay, three orders, 7 orders, 8, 5, 12, 14, 21, 13, 18. Make a note of that. 3. We are going to draw the box plot now. You do the same program in computer, you will see the box plot. Python, I am going to just create box plot of the whole. The same plot you can see with your eyes in the Python. So first value is what? 3, 7, 8, 5, 12, 14, 21, 13, 18. Okay, let us sort these numbers in ascending order. What are those numbers now? Tell me. 3, 5, 8, 7, 8, 12, 13, 13, 14, 18, then 21. That's all right. Right. So in the 5-point summary, the first point is called minimum. What is the minimum here? 3. What is the maximum? 21. Hey guys, this is what you saw in the Python. Just now you did the feature engineering. You saw the count, mean, Q1, Q3, I'm going to tell you. So the third one is called median. Median or mean value will take, right? So what is the median here? 1, 2, 3, 4, 5, 6, 7, 8, 9. The median is now. Median is 12. Suppose if this is an even number, you can take, suppose one more number is there. One more number is this side. Take 2 middle number divided by 2. Okay, wow. So far so good. Now we are going to find out quartile 1. What is that? Quartile 1. It is called Q1. Quartile 1. This represents 25% of the data. Q2 represents 50%. Q3 represents 75%. If median the Q1 is the lower half of the data from the median is representing Q1. The upper side of the thing represents Q3. So how we take it? 3, 5, 7, 8. 3, 5, 7, 8. From this, we have to find the median. What is the median? 5 plus 7 divided by 2. 12 by 2. What is that? 6. So Q1 is 6. We have to take the median from this lower quadrant median. Median is nothing. Q1 is nothing but lower quadrant median. I mean lower half median, upper half median. Okay. So what is Q3? Sulabha. 14 plus 18 divided by 2. 32 divided by 2. You know, 16. So now we have got our now we have got the box plot. We can draw the box plot now. Box and whisker plot. So easy, not a rocket science. What is the minimum value? 3. First you put one y x-axis, start from 0. 1. Start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. If the minimum is 3, are you here? Just put the dot there. Dot position. Minimum. This I am going to show you right now. You can see the graph. It will tickle out. In horizontal, it will tickle out. Upper maximum. Another 21. Oh. Maximum 21. Okay. What is the median value? Median value is 12. 12 is also 12. Okay. What is Q1? Q1 in a bar. Q1 6. Q3 16. Okay, wow. box plot. So this is minimum value, this is maximum value, this is Q1, this is Q3, this is median. So any data comes and line here is very good, line here is very good. Somewhat good depending on the problem. This is also good. If data is beyond this Q1, beyond this minimum, they are not good teacher for us. Okay, so this is called box and whisker plot. Now you can open the Python code and the box ஆகவே பார்க்கலாம். ஒரு திருப்பி வச்சு பாருங்க. அது இப்படி வரையலாம். Just see, then you will understand. நம்ம சொன்ன காருக்கு the car kilometers it has gone that box plot இருக்கு பாருங்க. இல்லனா it's a ஒரு code. அது இருக்கு பாருங்க minimum, maximum, mean இருக்கும். mean Q1, Q3. Q1 போட்டுட்டாங்க 25% போட்டுருக்காங்க. Q1 means 25%. Q3 means 75%. Stop பண்ணி போட்டுருக்காங்க. I'll send you one code.